Bohr's atomic model has successfully introduced the idea of quantum energy, and in explaining the formation of line spectrum for atoms, for example hydrogen, and ions such as helium plus and Li2 plus that contain only one electron. However, there are several limitations in Bohr's atomic model. 1. The theory could not be extended to predict the energy levels and spectra of atoms and ions that contain more than one electron. It only explained the hydrogen spectrum or ions contain one electron, for example He plus or Li2 plus. 2. Electrons are restricted to move in a certain distance around the nucleus of an atom. 3. Cannot explain the formation of extra lines in the hydrogen spectrum. 4. Unable to explain the dual nature of electrons. De Broglie postulate. French physicist Louis de Broglie strongly believed that particles such as electrons can also have the wave properties, that is, they appear to have dual natures. De Broglie deduced that the particle and wave properties of an electron are related by the expression lambda equals to h over mv, where lambda is wavelength of moving particles, h is Planck's constant, m is mass of particles, v is velocity of moving particles. Heisenberg's uncertainty principle. The uncertainty principle formulated by Werner Heisenberg states that it is impossible to specify the exact position and momentum of any moving particle at the same instant of time. It can be represented by the equation delta x times delta p equals to or greater than h over 4 pi, where delta x is uncertainty in measuring the position, delta p is uncertainty in measuring the momentum, h is Planck's constant. Since momentum p equals to mv, we can write the equation above as delta x times delta mp equals to or greater than h over 4 pi, where m is mass of particles, v is velocity of moving particles.